So for the test tomorrow, we're going to cover the whole unit. All right, so for today's notes, I'm going to do questions 57 through 66. So let's start number 57, right? When we started with logarithms at the beginning of this unit, I mentioned that logarithms were the way we're going to solve when the variable, right, when the letter is the exponent. So here we have log base m of p is equal to q. And I need you to write this as rewrite the equation in exponential form. Okay, so the way we read this to begin with, we said log base m. So my exponents, m, is going to be the base. That's what we call it as log base m. And then I know that logarithms are for me to solve for the variable, that when the variable is the exponent. So I'm solving for the exponent. So that means that whatever I have after the equal sign, it's the exponent. So I'm writing this as m to the q is equal to, and from what you guys can see, the only variable left is p. M to the q is equal to p. Okay, that's it. That's all we have to write. And then we said if we know how to write from logarithm to exponential form, then we should be able to do it backwards. So for 58, rewrite the equation in logarithm form. We have it in exponential, so we're going to write it in logarithm. I know the x, in this case x, because x is the exponent. That is what I'm going to have after the equal sign. The base is 9, so let me write this as log base 9 of y is equal to x, right? I knew x was going to be by itself after the equal sign. And that's it. Now, let's take a look at question number 59. Evaluate each expression. When we first started evaluating, we started using the base. And I know, well, 7 to the something. I know 7 to the third is equal to 343. Okay. Now, I would like to do 7 to the x, because I know log base 7 of 1 over 343. I know this is x, right? I don't know what it is, so I'm going to call it a variable. So I could write this as 7 to the x is equal to 1 over 343. Okay, so coming back to what I said a few seconds ago, 7 to the third is 343. Now, how can I do to get 343 but as a fraction and flipped? 7 to the negative third is 1 over 343. Remember, we already talked about negative exponents. What a negative exponent does, it flips my fraction. So instead of being 343, is 1 over 343. So I know here 7 to the x is equal to 7 to the negative 3. Right? Notice how I rewrote 1 over 343 as 7 to the negative 3. Okay, so again, 7 to the x is equal to the 7 to the negative 3. The base is the same, right? So I'm just going to let my exponents equal each other. X equals negative 3. And that's it. I was solving for x. I know to begin with, it says evaluate the expression. I didn't know what it was, so I called it x. So in reality, my answer is negative 3. Okay, so remember, you don't have to type in x equals. You just have to type in negative 3. And then we're going to use a calculator to approximate each to the nearest thousandth. Okay, before I look at the question, thousandth, that sounds like the number 1,000. Thousandth, because of the TH, I know is a decimal. It sounds like the number 1,000, right? 1,000 has 3 zeros. So thousandth has 3 decimal places. Okay, so my answer should have 3 decimal places. So log base 2 of 6.7. Now I cannot use bases here, right? If I wanted to do bases, I let this equal to x, and then I said 2 to the x is equal to 6.7. I cannot write 6.7 as 2 to the something. So I'm not going to be able to use the base. However, so let me cross this out because we're not going to be able to use that. However, log base 2 of 6.7, let me take a look at this. Log base 2 of 6.7. If you have a calculator where you can already just type it in, change the base, then just type it in and you're going to get your answer. If you cannot change the base, the only thing is your calculator only types in logs without letting you change the base. We're going to type this in as log base 6, log of 6.7 divided by log of 2. So one of these two ways is how we're going to type it on our calculator. Let me get a calculator out. In my case, I see that I can only do log base 10. It doesn't let me change the base. So I'm just going to type in log of 6.7 close parentheses divided by log of 2 press equal. I have to round this to 3 decimal places. So I'm going to round it to 2.744. Okay, 2.744. There you go. Then we talk about expanding and condensing, right? Expanding means you're going to make this bigger, right? It's one logarithm. I'm going to expand it. I'm going to spread it out. We know that multiplication spreads out as addition, and then division spreads out as minus. Okay, first of all, I should not have that parentheses there. So let me rewrite this as log base 5 of a to the 8 over b to the 4th. Do notice that the exponent that I had outside, in this case the 4th, got multiplied to each exponent on the inside, right? With the a, 4 times 2, you guys can see where I got the 8. The b, I don't see an exponent with the b, so technically it was a 1. So you guys can see the 4 times 1, that's where I got b to the 4th. Okay, so the exponent outside multiplied to the exponents on the inside. Then I'm going to break this out as log base 5 of a to the 8th minus log base 5 of b to the 4th. I split it as a minus because it was division. If it was times, I would have split it as plus. Okay, then I cannot have exponents. Any exponent, I'm going to bring it to the front of each log as a whole number. So I'm going to write this as 8 log base 5 of a minus 4 log base 5 of b. Notice how each exponent, I brought it to the front of each log. And that's it. 8 log base 5 of a minus 4 log base 5 of b. Okay. If you can simplify any logs, if I had numbers, then by all means do simplify. Now 62, we're going to condense. So we're going to go from a plus, from adding 2 logs to combine it into 1 log. First of all, so what we just did on 61, we're going to do everything backwards. First of all, the number in front of the log, let me bring it to the top as an exponent. So I'm going to say this is equal to, right? So I'm going to write this as log base 5 of 10 to the second plus log base 5 of 11 to the 8th. Notice what I did with the number in the front. I brought it up as an exponent. Now I'm going to be able to condense it into just 1 log. So I'm going to do log base 5. And let me do 10 to the 8th. 10 to the 2 times 11 to the 8th. So, as a matter of fact, let me put this inside parentheses so we know it's all together. So log base 5 of 10 to the 2 times 11 to the 8th. Now, to see if you're paying attention, right? I know multiplication, the order of multiplication doesn't matter. So inside of the parentheses, whether I write 10 to the 2nd times 11 to the 8th or flip it, it's correct. So just to see if you're paying attention, I might write this as log base 5 of 11 to the 8th times 10 to the 2. All right, I'm going to flip inside the multiplication just to see if you're paying attention. So that's how we condense. And then we moved on, at the beginning of this week, we moved on to use the properties of logarithm. So let me read the instructions here. Use the properties of logarithms and the logarithms provided to rewrite each logarithm in terms of the variables given. Okay. Now we have log base 4 of 9, log base 4 of 6, log base 4 of 10, but we have one that is not there, but log base 4 of 4. I mentioned that that's always going to be given. The base and the number are going to match, and when they do match, this is equal to 1. Okay, so we're going to have that. Another one that we have is log base 4 of 1, and that is equal to 0. Okay, so those two are free. They're not, we don't see it with they're not given, but technically they are. Okay, so those are free ones. We have those two as well. Now let me break this out. The question to begin with was find log base 4 of 9 over 4. So when I expand this, I know I'm gonna get log base 4 of 9 minus log base 4 of 4. Now log base 4 of 9, let me just replace that with an x minus log base 4 of 4, let me replace that with a 1. And I got those right here. Notice how the x was a capital X, so make sure you capitalize it. Capital X minus 1 all together, no spaces, all right? So just x minus 1 all together. That's it. Then let's move on to question 64. We learned that when we have log of something on both sides of the equal sign, right? Let me separate my equal sign. Let me separate my sides to the equal sign. And I notice that I have on both sides log base 15. I have the same log on both sides. What I'm going to do here, I'm just going to say negative x is equal to 14. Because I have the same log on both sides, I'm just going to ignore it. So I have negative x equals 14. I'm asking for solving, so I'm asking for the variable. I want to know what x is, not negative x. So let me divide both sides by a negative 1 just to get rid of the negative sign. And I'm going to get x equals negative 14. You don't have to type in x equals, just negative 14. So that's when we have the same log on both sides of the equal sign. Now, here on number 65, when I separate them to the equal sign, I see the logs only on one side of the equal sign. So not on both sides, only on one side. So let me condense the left side first. Let me condense this. So let me write this as log base 2 of 7 times x minus 4. And I know this is equal to 5. Notice I condensed it as multiplication, right? Because it was addition of 2 logs. So I condensed it as multiplication of 1 log. And I can rewrite this in exponential form because I have logs only on one side. So let me rewrite this as 2 to the 5th is equal to 7 times x minus 4. So I go from logarithm form to exponential form, right? We just reviewed that in question 57 of today's notes. Okay, I know 2 to the 5th, I can easily find that. 2 to the 5th is 32, right? Multiply 2 5 times. I know 2 to the 5th is 32, so I have 32 equals 7x minus 28. Notice how on the right side I distribute the 7, right? So that's how I got 7x minus 28. I'm really just solving for x. Okay, I want x by itself, so this minus 28 on the right side, let me move it to the left as a plus 28. I know 32 plus 28 is 60, so I have 60 is equal to 7x. To get the x by itself, let me divide both sides by 7. So I'm going to get the x by itself. Now 60 divided by 7 gives me a decimal. We're going to keep it as a fraction because decimals, we only rounding things up. I'm going to keep it as a fraction, 60 over 7. If you can simplify the fraction, by all means, do simplify. In this case, we cannot. So I'm just going to keep it as 60 over 7. Notice how my fraction I did the backslash, 60 backslash 7, right? 60 over 7. Okay, now our last question from today is solve each equation. Round your answer to the nearest 10,000th. Okay, because it ends on TH, I know it's a decimal. 10,000th sounds like the number 10,000. Now, 10,000 has 4 zeros. So 10,000th has 4 decimal places. The way I'm going to do this, let me write this in logarithm form first. So I'm just going to write log base 10 of 15 is equal to a. And it says solve the equation. So basically, I want to know what the variable is. I want to know what's the value of a. I expect a to be between 1 and 2, right? Because 10 to the 1 is 10. 10 to the 2 is 100. So 10 to the a is equal to 15. So I expect it to be 1 point something. Now, if you can type this in, log base 10 of 15, just type it in. If you cannot see, if the log was not 10, right? All of our calculators, they use log when it's not, when we don't see the base, it is log base 10. So I'm just gonna just type this in. Let me grab my calculator out. So I'm just gonna type this in, log base 10 of 15. Right, it says log of 15. When we don't see the log, that means base 10. Log of 15, it says 1.17609. I have to run it to 4 decimal places. I'm going to go 1.1761. Okay, let me come back to our work here. So I'm going to say this is equal to 1761. Okay, now if you don't remember what we just saw yesterday, how to solve these things, what if the base is not 10? What if the base is something else? Then you would do, if this is the case, I can type this in as log of 15 divided by log of 10. And if you type that in on your calculator, you should still get 1.1761. Okay, so you're going to use division of 2 logs if you cannot change the base, and the base is not 10. You might be like, so what do you mean with that? If I had, let's say I had log base 2 of 5, I will do log of 5 divided by log of 2. I type that in and I get my answer. Okay, so this is how you're going to do it when you cannot, when the base is not 10 and your calculator doesn't allow you to change the base. So let me zoom out. We did questions 57 through 66. There you go.